Now, what are we doing today? Our lab experiment was split into three parts. We had the catechol oxidase activity, the temperature test, and the pH test. What is catechol oxidase? If you couldn't tell by the name, catechol oxidase is an enzyme. It's found in fruits and vegetables. It contains copper, and when that's exposed to oxygen, it will create a brown color. And this brown color is a product of benzoquinone, which is a substance that is toxic to food-spoiling bacteria, which means that when, let's say you cut an apple, the exposed area will turn brown so that bacteria won't invade it and make it raw. Part 1. Catechol oxidase activity. Procedure. First, grab 3 test tubes and label them 1, 2, and 3. Second, pipette the precise amount of water and catechol into the specific test tubes. Next, you only add catechol oxidase before the incubation if needed. Next, the 3 test tubes in a 40°C hot bath for 10 minutes. After 10 minutes is up, you take the test tubes out and examine your results. These are the results of our catechol oxidase activity. On the left, this is before we placed the test tubes in the 40°C hot bath. And on the right side is the after, which is the result of putting the test tube in the 40°C hot bath. Continuing on with our results, we conducted the results with test tubes 1, 2, and 3 to determine which ones would have a reaction between catechol oxidase and catechol. Test tube 1, our positive control, which contained both catechol and catechol oxidase, which means that there will indeed be a reaction which results in a 3, which means that there is a defined color change, that it is completely dark, like really dark, clear brown. And test tube number 3 was our negative control, and this is when we were testing if there was no reaction, which indeed happened, because you can't have a reaction without catechol oxidase, which is the enzyme. And test tube 2 was our test, so we were testing if catechol oxidase will react if there is no catechol, and it did by providing a slight coloration, which resulted in a 1, which means slight coloration, and slight reaction occurred. Part 2, the temperature test. For this test, we were given a question. It is, what is the optimal temperature for catechol oxidase? And we are going to find this out by testing our hypothesis, and that is, if we increase and decrease the temperature of the environment of catechol oxidase, then the enzyme will denature and will no longer function. So that's what we're trying to find out. Now the procedure for test 2. Grab 6 test tubes and label them 1 through 6. Next, you place 1 ml of catechol oxidase into each test tube, and then place each test tube in a specified environment. Wait 10 to 15 minutes for the test tubes to react in their environment, then collect the test tubes. Then after that, you add 1 milliliter of catechol into each test tube and observe your results. So the scale which we're using is a 0, 1, 2, 3, which means 0 is nothing and 3 is the most. 2 would mean medium, and then 1 would little coloration. And the test tubes, we have 1, 2, 3, 4, 5, 6, and we used it as an increasing range. So 1 would be 0°C, 2 is 22°C, which is also known as room temperature, 3 is 40, 460, 80, and then 100. Here we have a video of me adding the catechol into our test tubes. As you can see, I didn't get it from the very beginning, but as you can see, as I pour the 1 milliliter of catechol into each test tube, there is coloration, which means that there is some reaction of catechol based on its environment. And though it's just initial, over time the catechol and catechol oxidase continue to react and provide a brighter color. So here are our results for the temperature test based on my clearly defined test tube labels, going backwards apparently. But test tube 1, 2, 3, and 4 had the darkest coloration, but as you can clearly see, 2 had the most defined brownish pigment compared to all the rest. So that we labeled as our number 3, which means the most change or most reactive. And then 1, 3, and 4 were second reactive because they had a definitely distinct coloration of brown. Yet 5 and 6 had very, very, very little or none coloration, so that's why they were 0. As you can see by my pretty little chart here, we see that test tube number 2 had the highest rate of reaction, so that's why it's at number 3. And then over time, as the temperature increased, the rate of reaction definitely decreased and then resulted in none as the enzyme denatured at a higher temperature. So as you can see, the lower, not really the lower, but the more suitable temperature, which is like room temperature, is the most suitable environment for catechol oxidase. So the conclusion for the temperature test, going back to the original question, we were trying to find out what the optimal temperature for catechol oxidase was. So based on our results, we were able to conclude that catechol oxidase's optimal temperature is at 22 degrees Celsius, which is also known as room temperature.